everyone. We're going to find the area of the region that lies inside the first curve and outside the second curve. So the first curve is a circle I have in black, and then the second curve is a cardioid that I have in red. Now, to find these points of intersection here, which is here and here, you set these equal to each other. So we have 3 cosine of theta equals 1 plus cosine of theta. Subtract cosine from both sides, you get 2 cosine of theta equals 1. Therefore, cosine of theta equals 1/2. So therefore, your angle is pi divided by 3, or negative pi divided by 3, or 5 pi divided by 3. So basically what we're going to do is we're trying to find this area that's inside this curve of the circle. And the graph is just a sketch, by the way, guys. So, and then outside the cardioid. And this is your pi divided by 3 right here. All right. So what we're going to do is look at just half of this curve. So we're going to go from 0 to pi divided by 3 and then multiply it by 2 to get this area. So we're going to just get this first area and multiply it by 2. So your upper and lower limits, your lower limit's going to be 0, your upper limit's going to be pi divided by 3, and we're going to multiply this by 2. So the area equals 2, because we're multiplying it. And we're going from 0 to pi divided by 3. And then we have 1/2 of r squared. So basically we're just going to subtract these two r squareds. So that's going to be 3 cosine of theta squared minus 1 plus cosine of theta squared d theta. All right, so this simplifies to equal, this 1/2 and 2 equal 1, so they can just go away. And we're going to have 0 to pi divided by 2. This is going to equal 9 cosine of squared theta. And then we're going to have minus 1 minus 2 cosine of theta minus cosine squared of theta. And I just expanded this, and then I also negated everything at once. All right, let's clean this up. This is going to give me the integral from 0 to pi divided by 3. This should have been pi divided by 3. This is going to be 8 cosine squared of theta. And then we have minus 2 cosine of theta minus 1 d theta. As usual with integration, when we have this square like this, it's best to use your identity as, let's write the integral from 0 to pi divided by 3. And we're going to write this as 8 times 1/2 times 1 plus cosine of 2 theta. And then we're going to have minus 2 cosine of theta minus 1 d theta. So all I did was simplify this using identities. This is going to equal 4. So you're going to get, and I'm going to write it in here, this is going to be 4 plus 4 cosine of 2 theta. So we're going to subtract this, and this is going to give us, let's see, the integral from 0 to pi divided by 3. So we had 4 minus 1, that's going to be 3, plus 4 cosine of 2 theta minus 2 cosine of theta d theta. All right, let's integrate this. This is going to equal 3 theta plus 1/2 of this, so that's going to be 2, and then we have sine of 2 theta. I just took half of 4. And then we're going to have minus 2 sine of theta. And we're evaluating this from 0 to pi divided by 3. So let's see what we get. We're going to get this equals 3 times pi divided by 3 plus 2 times sine of 2 pi divided by 3 minus 2 times sine of pi divided by 3. All right, this is the zeros is just going to zero everything out, so we don't have to do that lower limit. This is going to give us pi plus, this is going to equal, this whole thing's just going to equal square root of 3. So we're going to have, this is 2 times square root of 3 divided by 2. So it's just going to be square root of 3. And same thing's going to happen. It's going to be minus square root of 3. So finally your area is going to equal pi plus square root of 3 minus square root of 3. And that's it. Thank you. Have a nice day. Bye-bye.